Hello students, this video will walk through an example where you are given the Ksp value for a substance and asked to find its solubility. And then can we rank substances from lower to higher solubilities given Ksp values? So digging in, this is from the student note packet, page 3. So let's imagine that we have copper 2 iodate, and we're given the Ksp, and we're asked to find solubility. All right, for insoluble solids, we just have to remember that solubility is our X. That is what we are after. So we are always referencing the ionic compound as our reactant, and it will partially dissociate to give us 1 copper plus 2 for every 2 iodate ions. Okay, so if we are proceeding forward with an ice table, solids do not impact our equilibrium position. Our K is copper plus 2 to the first, our iodate to the second, and of course, because it's describing insoluble solids, it's Ksp. All right, we are not told anything about starting in our solution with these. And so we're imagining that these are just being created. And so we start with 0 of these. Respecting the mole ratio in our coefficients, we will make 1x of our copper, but 2x of our iodate. So we have x and then 2x. Okay, the Ksp value, 1.4 times 10 to the minus 7th. So we just need to find our x. X reveals the amount of this that will yield that solubility. And so x and then 2x squared. If we want, we could go ahead and get that to be 4x cubed and then go from there. And the x, which is our solubility, will be 3.3 times 10 to the minus 3rd, and we know it'll be mole per liter. Okay, and we're done. So we just have to be really careful making sure we're respecting the mole ratio of our ions and applying the law of mass action. All right, well, what if you would be given different Ksp values? For example, okay, we know Ksp is the concentration of ions over 1. So because it's product or ions over 1, we know the greater this value, the greater the concentration of ions and therefore the solubility. So the greater the Ksp, that means the greater the solubility. Now, you just need to take care because we can only directly compare Ksp values when our substances create the same ratio of ions. So PbCl2 is 3 ions. And so, our Ksp will end up being Pb plus 2 or x, and then 2 chlorides squared, 2x squared. And so this ends up being 4x cubed. So because both of these have the same Ksp expressions whenever we communicate it in terms of x for our solubility, again, because they have the same number of ions, the same charge ratio, then we can directly compare their Ksps. So this is the larger, and so lead 2 chloride would be more soluble. So the solubility of PbCl2, we're going to have a greater concentration of lead plus 2 and chloride ions versus the solubility of PbBr2. And the same thing here. So here it would just be Ksp because there are 2 ions and a 1-to-1 mole ratio and charge. This is just x squared same for here. So we can do a direct comparison. And so the solubility, this is a much greater value, would be greater for silver chloride than silver iodide. So we just have to really be careful. On that page 3 of your student note packet, they are asking to rank these salts in decreasing solubility. Well, our CUS is 1:1, and so our KSP will end up being, in terms of solubility, X times X, or X squared. Our silver sulfide, we have 2 silver ions for every 1 sulfide. So then our KSP is going to be 2x squared times x. And so this will be 4x cubed. And then that bismuth sulfide, we get 2 bismuths for every 3 sulfides. And so this KSP ends up being 2x squared times 3x cubed. So here's 4x squared, 27x cubed. So this is going to be 107 x to the 5th. And so then if we actually go ahead and plug in our KSP values and find x, the x value, the solubility for copper plus 2 sulfide is actually 9.2 times 10 to the negative 23rd. The x for silver sulfide will be 10 to the negative 17th. And for the bismuth sulfide, it's 10 to the negative 15th. So upon face value, it looks like this is such a small value. So we would just naturally want to say this is the least soluble. But we can only directly compare KSP values if the dissociations are exact, and then we end up with the same kind of solubility and KSP expressions. And so if it's decreasing solubility, then it's actually your bismuth sulfide is the greatest, and then the silver sulfide, and then the copper sulfide. Okay, so that walked us through how do we find solubility given KSP, and then just taking care whenever you are ranking solubilities given KSP values.